So the review that you see here is in Google Classroom. So please do this along with me, and then we will submit this as soon as we are finished with it. You're only going to do the ones that are highlighted. So there are some we're going to skip. I just picked out the ones that were most like what we're going to see on the quiz tomorrow, so you had this to study with. So let's take a look at problems 1 and 2. So in problems 1 and 2, we're using the graphs that you see here to determine if they are functions, and then to determine if they are one-to-one functions. So remember, for something to be a function, it should pass the vertical line test. So you'll see all vertical lines hit that only once. So A is a yes. But B, if you notice, we have many, many different vertical lines that hit that circle in 2 spots. So that would be a no. And then C passes the vertical line test. All vertical lines only hit it once. So it's a yes. Now, for number 2, where are the functions one-to-one? It has to be a function in order to answer that question. So right off the bat, we know B can't be one-to-one because it's not even a function to begin with. So now we are looking, does it pass the horizontal line test? So you'll notice that a horizontal line hits this graph in many locations. So A is a no. And then C, if we check every single horizontal line, it does actually only hit it once. So that one is one-to-one. So I'm going to give you 3 graphs, and I'm going to ask you, are these functions, are they one-to-one? Now let's look at 3A. It says, which one of these, or which of these tables represents y as a function of x? So just like before, if something passes the vertical line test, that means the x's did not repeat. So the problem I see with the first table here with our x's, I mean, there are no problems. The x's are all different. So yes, that's a function. But the second one, we have these x's, the 3's that repeat. So they are lined up vertically. So that's no. The third table, all of the x's are different. You see all those x's are different. So that's yes. In this table, we have those ones that repeated themselves. You'll notice our ones repeat. So that one is a no. So then B says, from the tables, which ones are one-to-one? So remember up here, you're asking yourself, do the x's repeat? Here, you're checking, do the y's repeat? If the y's are all different in our charts, now remember, we only care at this point about this one, only the yeses. So we only get to check those 2 charts. And so in table A, you will notice all of our y's are different. So our first one is one-to-one. But our third one here, do you see how we have these 3's that repeat? So this one is not one-to-one. Okay, so there are 2 that are functions, 2 that are not. Of the 2 that are functions, one of them is one-to-one. Any questions about that one? Okay, so if the x's repeat, it is not a function. If you find it's a function and the y's repeat, it is not one-to-one. So here we had a repeat in the y's. That's why that one is not 1-to-1. Here, all of our y's are different, so it is 1-to-1. It's like every x is paired up with one y, every one y is paired up with one x. That's what that means. We good with 3A and B? Mm-hmm. Yes. Yeah, so you only, a one-to-one it is a one-to-one function. So you could even put the word function there, and I might have actually put that there. Okay. Let's take a look now at 4 and 5. So on 4 and 5, it says evaluate f at 1. So you're going to go to an x value of 1. You're going to go up onto the graph, and really f of 1 is just the height. That is the point 1, 3. So that tells us that f of 1 is equal to 3. Now, the next question is different. The next question is asking, what is, or where is f of x equal to 1? So that is really saying, where is the height? 1. So I think about the fact I am looking for where the height of the graph is 1. So where would a horizontal line that is 1 hit in it? So this is the point 2, 1. So that means that an x value of 2, my f of x was 1. So the first one, you know, that is your x. The second one, that is your y. Okay, so if they word it like find f of 1, that is, what is the height when x is 1? If they say when is f of x equal to 1, that's a different question. That is saying, where do we have an x value where the height is equal to 1? Does everyone see the difference in that? Now, in the table, it's kind of the same way. This is an x value of 8. What is your y? That's all that's saying. So if we go over to our graph paper, when x is 8, the answer is 94. But in the second one, this is saying my y, or my height, is equal to 1. What is the x where that happens? And that is one you could possibly get to. You can get repeats of that. So if there's more than one, just tell me that. But the y is equal to 1. The only one I see is that one right there. So when an x value of 5, we have a height, or a f of x, that is equal to 1. Does everybody understand the difference of how that question is asked? Okay, let's look at number 6. It says to calculate the following values. I'm only going to do a few of these, just because once we do a few, we'll get the hint. So scratch out those ones. Let's just do f of -2 and f of 0. When plugging in -2, you're going to replace the x's with -2, and I would suggest to use parentheses. If you use parentheses, you are less likely to make those funky little mistakes that we all make. So this is really 6 times 4. This would become a positive 4 because it's touching a -2. It'll switch signs, which is 24 plus 4 plus 3, which is 31. Okay, so you're just sticking that into the function. If you don't have a graph, they have to give you a function to actually do that. Now, in f of 0, when we input 0, you can do exactly the same thing. We're just replacing our x value this time with 0. What's great about plugging in 0 is the fact that every term that had an x becomes 0, so we just get 3. So plug it into a function. I think you guys are good with that at this point. Any questions about number 6? We are going to be skipping 7. Hopefully you know your parent functions by now. We're going to skip that. That is not something I ask you on the quiz. Yes. Yeah. Yeah, I'm going to skip some here and there. Yeah. If I skip it, you skip it. You don't have to do it. You're going to just do exactly what I do. Okay. Let's skip down, please, to number 9. Number 9 says to find the domain and range of the function graph. Remember, our domain are the x's that are used from left to right. So let's do that to begin with. That is the domain or the x's we use from left to right. So as my math bug walks along this graph, the first x it can get to is -3. It can continue to all the x's until it gets to 1, and it does have a problem there. And so if we think about the lowest x that I can use is -3, but there is a little closed-in dot that I can stand there. The highest x I get to is 1, but I can't stand there, and I can get to any x values in between. So that is our domain. Now remember, range are the y values that you hit. If you have an open circle in one y value, but you've colored it in somewhere else, you don't have to worry about it. Okay, so I can stand, the lowest I can get to is -5. I can get to everything, 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 everything. Now that I think about 3, is there a spot somewhere else on the graph that I could stand at a height of 3? Yeah, so don't worry about it. Don't worry about it. But what's the highest I can get to? 4. We assume that that means because they have drawn that graph like that, that point is included. And so our range, remember, are the y's from the bottom to the top. Okay, so our range would be from our lowest value, -5, to our highest value, 4. Everything in between was covered, and we could stand at those locations. So that's our range. So I will be giving you one where you have to find the domain or range from the graph. The domain or range from the graph, okay? And I do want your answer in interval notation. Now let's jump to number 10. In number 10, it says to find the domain of this function. Now, if we have, and I didn't note one like this, but if our function was just something like x² plus 2x plus 3, there's nothing that messes that up. I know that's not on there, but I just wanted to note that the domain of that is all real numbers. There's nothing that screws it up. I can plug in whatever the heck I want, okay? The thing that screws up our number 10 is, remember, the denominator is not allowed to equal 0. So if we could pinpoint that location, where is the denominator going to equal 0? That is the only value you have to remove. So just do x minus 3 equals 0, solve that. And then once you're done solving it, put a little slash through it. I know that x is not allowed to equal 3. Now it can be every other number on the number line but 3. If you were looked at the graph, there's what's called a vertical asymptote at that point. So our domain for this one, I would go up to 3. I would jump across it, and then I can keep going. This is the excluded value. That is the value that I skipped. I skipped 3. Now, if there was more than one that you're skipping, you would skip the first one from left to right, then the next one, then the next one, you know, however many there happen to be. But just set your denominator equal to 0, skip that value. Now, if our function is like number 11, for a square root, if you want to know the denominator is always where the inside is greater than or equal to 0. You just have to solve that inequality. So you just have to recognize if it's a polynomial, it's all real numbers. If it's a fraction, I'm going to remove any excluded values. If it's a square root, set the inside greater than or equal to 0. So I'm going to set negative 2x plus 1 greater than or equal to 0, and I'm going to solve it. Now, the rules of inequalities say as long as I don't divide or multiply by a negative, it's just like an equation. If you multiply or divide by a negative, you have to turn the symbol. That's the only time, unless you're turning the whole problem. Okay, so let's solve that. We're going to subtract 1 from both sides. And now, when I divide both sides through by negative 2, because I'm dividing by a negative, I have to turn the symbol the next time I write it. So I'm going to get that x is less than or equal to the fraction 1/2. Now, the domain is just that on the number line. So we would have a closed-in dot at 1/2, and we would shade to the left. So I want your answer, please, in interval notation. So the domain for this one would go from negative infinity up to 1/2. It can include it. The only time it wouldn't be equal to 0 is if your square root is in a denominator. It can't be equal to 0, but the rest of the time it's a bracket for a square root. It's going to be a bracket. Okay. So those are the 3 types of domains you want to remember for equation ones. If it's a polynomial, it's all real numbers. If it's a denominator, take the excluded value out. If it is a square root, just set the inside greater than or equal to 0. Have any questions about the domain if we're given a function? Okay. We're going to skip number 12. Could we please look at 13? Yeah.
After we skipped, which it was really high up. After we skipped 7, did we also skip 8?
Yes, we did. Okay, let's go to 13. So 13 says, based on the graph, estimate to 1 decimal place the average rate of change from x equals 1 to x equals 4. So all we're going to do, sometimes, and I think I might have written out on the quiz, that I say on the interval from 1 to 4. It means the exact same thing. Starting at 1 and ending at 4, what is your average rate of change? You're going to do it exactly like this. You're going to go to the graph, find an x value of 1, go up to the graph, put a dot, label that point. Now we're going to go to an x value of 4. We're going to go to the graph. We're going to put in our point, label that point. The average rate of change is just the slope between those points. You guys know how to find the slope between 2 points. You just do y2 minus y1 over x2 minus x1. So make sure you know that formula. So it doesn't matter which one you call x1, y1 and which one you call x2, y2. It is kind of customary to make the leftmost point x1, y1 and the rightmost point x2, y2. It doesn't matter. As long as you're consistent in the formula, whichever one you call x1, y1 and x2, y2, it'll work itself out. But if we use the points that they gave us there in that order that I was talking about, it's going to be 3 minus 5 over 4 minus 1, which is negative 2 over 3. If you get a fraction that can reduce, reduce it. If you can't reduce it like this one, that is our average rate of change. That's our answer. Okay. Now, I've given you one where they have given you the graph. Did I give you one where we did have a function? Just let me look real quick. I did not. So let's actually skip 14. just for time's sake, okay? But if they gave you the function, you would plug in the 2 points, you would get 2 points, you would do the same thing. Okay. So now if we could please move on to 15. Says the graph of the function is given, and it says where is the function increasing and where is the function decreasing. Now remember, if it is increasing, we are talking about the y's are increasing, and we're going to talk about what x. Those are our intervals. Okay. So first thing I would do personally if I was getting this as my problem on a quiz or a test is I would label the dots of my high and low points. And then I would make my uphill pieces one color. So there my bug would go uphill. And then for my downhill pieces, I would make it another color. Okay. So if we follow along the number line from an x value of negative infinity until an x value of negative 1, my function is going down. Or no, I'm sorry, it's going up. It's going increasing. From a function value of negative 1 to a function value, I think it's about 1.5, my function is going downhill. And then from an x value of about 1.5 forever, my function is going uphill again. Yes. The interval that is always the x is where that is happening. So the interval we're going to put on is related to the x's. So my y's are increasing for these x's. My y's are increasing for these x's. My y's are decreasing for these x's. Does that make sense? So if our line is going up, so my y's are going up for this x range, my y's are going up for this x range, okay? So let me show you how to write it. So the y's are increasing from an x value of negative infinity to an x value of negative 1, and then again from about 1.5 to infinity. Okay, so my x's, the y's are increasing to an x value of negative 1, and then the y's start increasing again from 1.5, and then it keeps doing that forever. Does that make sense how I wrote that? Okay, those are, the intervals are the x's, the word is the y's. So my y's are decreasing just in that middle section from an x value of negative 1 to an x value of 1.5. Now, do you see where it says where are the maxes and mins? So label this point, and just you're going to have to guesstimate. That looks like it's about 1.5 is what I called it earlier. And then the height is about, I would say, let's go negative 1.7. And then this one is, I thought it was negative 1, and it looks like it's about 0.8 or 0.9. You're going to guesstimate a little different than your neighbor because you have to guesstimate. If it lands somewhere, great, great. But if it doesn't, just guesstimate. And then label what these are. This is a local max. And this is a local min. And, this is going to be, you can do this, just label the graph. Just label your graph. What are the points and what they are. So just label it right on your graph paper. Okay? So remember, the answer are the x's. Where that happens are the x's. Anybody have any questions about 15? Okay, I'm going to let you write that down, and then I'll take more questions if anybody has a question. Okay, now we're going to skip to 16. The first thing I want to talk about for 16, I want to talk about what the notation is really asking you to do, okay? We're only going to take the time maybe to do a few of them, but I just want to show you what the notation means. So this first one, f plus g of 7, that's really just take 7, plug it into f, take 7, plug it into g, and add those up. That's what that notation means. The second one, you're going to take 3, you're going to plug it into f, and you're going to subtract when you plug 3 into g. The third one, that is just f of 8 times g of 8. And the last one, that is just f of 4 divided by g of 4. So don't make those notations harder than you have to be. These ones are pretty nice. So that's just what those mean. Now let's just take a moment to do, maybe we'll do the first one and the last one, okay? So the first one, if I plug 7 into the top function, I get 49 plus 28 minus 21. What is that? Can somebody help me here? Is that 56? Thank you. Now I'm going to plug 7 into my g function. I get 7 minus 3, which is 4, and then you just add them up. So it's just the f of 7 plus g of 7. Okay. Let's do the bottom one. F of 4 is 16 plus 16 minus 21. So that is 32 minus 21. Is that 11? 32 minus 21, I think that's 11. And then we're going to stick 4 into our g function. 4 minus 3 is 1, so that's 1. It can reduce. If it can't reduce, leave it. If it can reduce, reduce it. 11 divided by 1 is 11. If you would get a division by 0, just put that it is undefined. Okay, I'm not going to worry about doing the other two. I think you probably get the hang of what you're doing for those ones. I hope. No. It could be any of those. We are going to do a few more, but the review itself, just the ones I've done, would be like what you would get to see on the test. You may skip as well. Just skip those. Okay, let's jump now to 18. So we're going to use the graphs to find a composition. So start with the inside, work your way from the inside out. So we're going to plug 1 on the g function. So we're going to go over to the g function. We're going to find g of 1. G of 1 is a height of 4. So that means now we're going to find f of 4. So we're going to go over to the f function where the x is 4. We're at a height of 1. The answer is 1. Okay, so let me do it again. I'm going to go to 1 on the g function. I go to 1 on the g function. I find I'm at a height of 4. So now I put that in to my f function. If I put 4 into my f function, I am at an answer or a height of 1. Everybody okay with that one? Okay, now let's do the bottom one. If I plug 5 into my f function, I get 1. So this is really just g of 1. It's like those ones we kind of connected with the table, okay? So if I go to 1 on my g function now, am I totally backwards? Wait a second. Yeah, wait. I totally was not going to the right function. Did I screw up the other one? Oh, okay, let's go. So anyway, let's start again. Okay. So I'm starting on the f function, which is over here. I'm going to an x value of 5, and I'm actually at 4. Thank you so much. You guys were looking at me like I was crazy, which I was. So 5 has a height of 4. Now I'm going to go to the g function, and I'm going to find an x value of 4, and I'm at a height of 5. Hopefully that made more sense. So start with the inside function, work your way to the outside function. Okay. You guys okay with that one? Okay. Let's go to 20, but I am going to go back to 19. Okay. Let's do 20 just because it is a similar, it's very much like 18. Okay. So we are going to start with the g function and look at what happens at 3. So when x is 3, our g function is 4. So now we're going to do f of 4. Okay. So now we're going to go back to the table. We're going to find an x value of 4, but this time we are using the f function, and the final answer is 2. So g of 3 gave us a value of 4. We went back to the chart, and 4 gave us an f value of 2. Yes. Yes. This is the x that you're using for the g function. So the inner input, you're always inputting an x, so that's your starting place. So I start with the x on my g function, find out where it takes me, and then now we start over again, and now we're at x again for our f function. The input is always an x value. Good question. Are we good with 20? Okay, now I'm going to go back to 19 just because we need to be able to do one like 19 as well. Okay. So the first thing they asked me to do is to find f of g of x. So the first thing I want you to get used to is taking out that notation and writing it as f of g of x as my input. So that notation means f of g of x. I'm taking the f function, I'm plugging in g of x. So in that spot, as an input, let's write x minus 9 right there. And then remember what our f function's job is. It squares the input and it multiplies it by 4. So we are going to have to square the input and multiply it by 4. So just surround it in parentheses. So I'm going to, x minus 9 is my input. I'm going to square it. I'm going to multiply it by 4. Now be careful when you square x minus 9. I would take on the side of your paper and I would write it twice so that I remember that I have to FOIL. And so you get x squared minus 9x plus 81, or x squared minus 18x plus 81. So you do have to FOIL that, okay? So we get this thing we found after we multiplied it was x squared minus 18x plus 81. So let's put that there, x squared minus 18x plus 81. Now this 4 is in front of the parenthesis, so that tells us to distribute that positive 4. And so we get plus 4x minus 36. And then our answer, we're just going to combine like terms. So our final answer would be x squared minus 14x. 81 minus 36 is 45, so that would be plus 45. Okay, so my input was the g function x minus 9. I had to input that into the outer function. Now the difference between A and B is the input. The input is the innermost function. So for B, we are going to take the g function and we are inputting f of x. So it's the exact opposite thing. So let's write in our input. Our input is this, x squared plus 4x. Now this time, it is our input. It is our input right there. Very simple. We input it minus 9. So that is just going to be that input minus 9. Now luckily our input is just sitting there. The parentheses doesn't really matter. And you can't do anything. It is just x squared plus 4x minus 9. Now, even if it's a factorable quantity or something like that, who cares? It is, I inputted this thing, I simplified it as much as I possible, and that is my output. I am done. Don't care, you don't have to do it. The only time, there are times where that's helpful. It's usually only helpful if they've asked you another question about that composition. So if they asked you maybe, where are the intercepts, what is the graph, something of that sort, then it's a little more important. Okay, any questions about 19? So only the ones that I have done would be the things to look for and to study on the test, or on the quiz. It's over 3.1 to 3.4. Since we finished this, please turn this in at this time so that you get your points for it. Yesterday we finished the notes, so you should have those done. Turn those in now, get yourself some points for those. If you aren't done with the notes, the videos have been posted. Quiz is tomorrow.